Could you hear me?
Yeah, who was that?
Wait, you can hear me?
Yeah.
Oh, okay, okay. I thought my thing cut out. Wait, are you talking to me? Can you say my username out?
Yeah. Can you rename yourself to
Oh,
your
okay,
name?
okay. Sorry, sorry.
That's fine. Okay. Um, cool. So, all right. Today, does everyone have this pulled up? Just give me a thumbs up, and if it doesn't, just let me know.
Like where do we can you like type how like we should Jupyter Lab, like I need to reopen it.
Like, you want to open it again? Okay, so you have your navigator, right? You can do this
No,
either.
no, no, not that. Like I have it already open. I just need to type Jupyter Lab. I don't so like how, what is it spelled like?
What is your question exactly?
Like we have to after like clicking that the Anaconda prompt we get like that
Black screen?
area,
Yes.
right? So like what do I
Did you
so
type
like
in
do I
Jupyter
type
Lab?
Jupyter Lab like when those
Yes. So
not yet. Like I don't know this.
it's spelled like this. You just type that into your like. Let me show you. It's called Anaconda prompt. You just click on
Okay.
it and then type it in there. Just copy and paste that. And then it'll open up something. Yours is probably not gonna have anything, or it'll show you something. Let me see if I can pull something up. Okay, if it doesn't show you anything, uh, what you can do is it'll probably have like your files here, and
Yeah.
just create a new folder and call it like you can click create a folder by clicking this, but I'm not gonna do one. Then you can just call your folder whatever you want. Just say like workshop code or something like that. After you create the folder, let me know. And then I'm just gonna delete this since I don't need it. Uh, go,
Okay.
but
Where do we
just let me
search
know.
up like where do we search up like Jupyter Lab?
It's on Anaconda prompt. So do you have it downloaded? Do you have Anaconda downloaded?
Yeah.
Yeah. So you can either do it two ways. You can go to the navigator, the Anaconda navigator, and there should be an area. Hold on. This is okay. Yeah. Right. It's kind of slow on my side through the navigator, but there should be something called Anaconda prompt, and then you can just click on that
Yeah.
and then
Okay.
launch that. Yeah. After you launch that, you just type in whatever I put in the chat. Monvic, I'll send out the recording, but so you don't need to record, but if you want to, you can.
So I just type Jupyter Lab in the prompt.
Yeah. It's not
Okay.
spelled exactly like Jupiter, but you can see the spelling in the chat.
Okay.
It says kernel. What do we do? It says select kernel in Jupyter Lab. What do we do? Okay, can you share your screen? And it might be easier if one of you guys can share your screen because I have everything set up already. So just if someone wants to share the screen, that'd be good. Yeah, just give it a second. It's gonna load.
And what do I type here?
Just don't type anything. Just wait. Okay, yeah. It should have automatically opened it. But scroll all the way down. There should be a link. Do you see that? It says copy and paste that link. It's like right there. Yeah, there's like two links, right? Do the one on the top
Oh, yeah.
and copy and paste it into your Google.
Hello?
Okay.
I have a question.
Yeah.
For the do I press Windows for the Anaconda?
You don't have to have Windows. You can use,
No, it says distribution installers download. Do I press that?
yeah.
Yes, download.
It says localhost refused to connect.
Go back to the prompt. Do you close it? You're not supposed to.
No, it
Oh
held it.
yeah. Okay, run. You accidentally clicked Control C too many times. That undoes it. So you have to click up on your arrow key. Yeah, enter. Okay, just don't do anything and then just refresh that tab.
Let me try it on regular Chrome.
Yeah, go back to your prompt. You're not supposed to do Control C. Let me scroll down all the way. Okay, yeah, it didn't finish running yet. Yeah. Wait until it finishes running and then
Okay.
okay. Did it move any?
Yeah, I moved a bit.
Okay. Okay, we'll get to that part. Socket. Okay. Yeah, okay. Okay. It should work probably. Probably now it should work.
So do I?
Go to your tab. No,
Oh,
don't do anything there. Just reload it. Okay. Yeah, I'm not sure then. It should just work for you. Oh, it's loading right now. Yeah, I think it's gonna work. If it doesn't, you can just follow along for now, and then I can help you after class.
okay.
Yeah, it's fine. I guess we can come back to this later. I can help you after class. We'll just
All right.
move on since we don't have much time today. So since we have to finish what we had tomorrow yesterday. So
Okay.
yeah. So once you guys are in, right, I said create the folder so you can go create new folder. You'll probably see your directory on the left side. So you can just go find your directory where it is. And then there would either be an area here where it says create new notebook or something. Click that. If it's not there, you can just click new in the folder you just created and click new notebook. So once you create a new notebook, let me know.
Wait, can can you say that again? I didn't catch that. Can you say that again?
Yeah. So just create a new notebook like this. Just right click and then new notebook or click on this plus. And then yeah, you can just add in new notebook here.
Oh, okay.
Okay. Once you guys are there, just put a thumbs up, and then we'll get started. Okay. Before that, though, could everyone turn on their videos? We're gonna do a quick picture, a group picture. Okay. Nice. All right. Cool. All right. So I'll count to three. That's fine. I'll count to three and just smile, all right? So 1, 2, 3. Cool. I got everyone, I think. Yeah. Select kernel. Dia, can you share your screen or like send a screenshot of what you're seeing? Oh yeah, just click select. Yeah. And then create a folder on the left. Or you can just use that, I guess. That's fine. Okay. All right, cool. Let's get started. So since everyone's there, let's get started. Okay, so remember when we were learning about linear regression models, we did a lot of like complex math to kind of understand what it was, right? Code-wise, it's actually super duper easy, but understanding the logic behind it, theory behind it, it's really important. So let's get started with what we're doing. So everyone, I want you guys to import these files. So these are libraries that we can use. So we're using it from sklearn, and we're just importing in their linear model, and we're going to be using linear regression model. So that's the model that we were learning last time. So there's already libraries that do a lot of the complex math for us. Unless you're creating your own like fully customized networks or something like that, you wouldn't, for the most part, there's already stuff that can help you with it. You're just going to fine tune these things. Remember the parameter things, you're going to fine tune those and different things like that. But for the most part, everything is already created for you in these libraries. So all the math that we were learning yesterday is already done for you. So after you create these imports, what you're going to type out is, okay, all this section of the code is, I can just copy and paste this code. The code itself, writing the code itself is not the important thing. The important part is understanding what the code means. So I just put in the chat like what the code is. So all this is just I created my own data set since it's just easier to create your own for an example. I just created my X variables, right? So you have your x-axis, and I'm creating the variables that go in the x-axis, and then I have my y-axis here. So let's just say, for an example, that this is study hours, and this is your grade, your average grade in that class. Let's say a student studies 1 hour and they get a 50. Another student studies 2 hours, gets a 55. Okay, simple as that. Whenever you want to do an X array, you have to always put these in brackets. So you have your original bracket. So right now we're using Python to code these models, okay? So we have our original bracket that has all of the arrays. So I'm sure you guys seen this in your computer science class. You have your bracket, then you put in your array, you do a comma, and then you get to the next point, right? But whenever you're talking about the X value, you want to always put double brackets, just like this. And then for the Y array, you do the same thing. You do the same thing, but you're not doing the extra brackets. That's how the code knows to distinguish it between the independent and dependent variable. And right over here, you have your linear regression model. So I created a variable. A variable is basically just something that contains data. So to give an example, 1 second, I need to answer this question. Okay, so Akshay, right now, yesterday we learned about linear regression, right? So, what we're doing today is just building the actual model on Python. So, make sure you have your Anaconda environment opened up like this. If you don't have it opened up, I can show you maybe later after I finish this demo. But, getting back to where I was, so we create a model in a variable. So, what a variable is let's draw a picture here. Let me draw something. Okay. So I'm just gonna create. Okay, yeah, that's fine. Okay. So imagine you have like an empty. Oh yeah, let's say we have a crayon box, right? And we have crayons in there. Okay. And let's say the crayon box itself is an empty container. And let's say we start off with 0 crayons. So whenever we call this crayon box, we will say there's 0 crayons in the crayon box, right? It's holding nothing. But now let's say it holds 1 crayon. So now we have 1 crayon inside our container. Same thing with this variable here. The variable itself, when you declare it, it's empty. It has nothing, no value. And the great thing about Python is you don't have to explicitly state this variable as a number. Like for example, in Java, you have to say int model. You have to say string model. It just means you have to state whether it's a number, a value, different things like that. So that's a really good, useful thing about Python is you don't need to state anything. You just can hold a bunch of things. Like this crayon box can also hold like markers, for example. So that's all a variable does. It just stores information. That's pretty basic stuff. That's not what we're trying to get at here, actually. So this model now holds the linear regression. So all that complicated math can now be done super easily just by creating this model. And we created linear regression model. And what this does is model.fit x and y. All that does is it grabs in our variable here that we created of our x data set and our y data set. Okay, so yeah, model.fit now trains the model. So remember the equation that does this? We have n I equals 0, and then we have yi minus y hat. You guys remember this equation, our training equation? Well, that's all done through this model here. All of it is already fit inside of this one line of code. So now the model runs through all of these data points, right? It goes through all our input. We go through each one of our input data, and it runs through it and trains the model. And then finally, it makes our prediction. We store it right here in yPredict and does model.predict x. And then it does the code, the math for the prediction. So it does this equation here, wx plus, right? So in these 3 lines of code, we're doing 3 different equations. We're doing our training equation, and inside the training equation, we have our optimization equation that's already being used. The optimization equation is not the same. sklearn has its own optimization. Like I was saying, that was just an example of an optimization equation, but sklearn does the optimization for us, so we don't really need to worry about it. And I'm sure they use a different formula anyways. But That's how this part of that works. And all this is, it's just a print equation, print code, and it's just printing out like M, the value for M and B, so our parameters. And then it's just printing those values out. And all this code does here is it just plots, um, it's just creating our graph here, like just creating the interface for it. So it's just saying, okay, we want the x axis to be this value, and then take our y axis for these values, and I want the dots to be blue. So it's just plotting out all the dots, and then it's right here. It's just plotting it out the line. So the actual red line here, it's plotting it out. So the red line, it says y predict. So guess the line that this model just created here. So it's just putting in model.predict x and then setting the color to red. And then we're just labeling it predicted line. And then we're just labeling our x and y axis and then creating a title. So that's all it is. But the most important thing here is is these three lines. So does that make sense for everyone?
Yes,
Yeah.
sir.
Yeah.
Yeah,
Yes.
perfect. Yeah, that's all we have. This other equation, all I did was I have a data set here. It's literally the same thing, but instead we're loading in a data set. So this data set you guys can take a look at. All it does is oh, is my camera off? Okay. Okay, perfect. Okay, so all it does is it takes in the hours and the score. So we have, a random data set of hours and scores for each one. And this is where prediction gets really useful, right? So we plot in our data set. We do data equals PD dot read CSV. So whenever we work with dataset loading, we use a library called pandas. And this is the import you would use. Import pandas as PD. Everything else is the same. So you have your matplot. So matplot is all just printing it out, used for printing stuff out, like math stuff. And then we have our library, so sklearn, linear regression model. And then this time I'm using the mean squared error, right? That's just the equation for the loss function for the training stage. I was just trying to show you guys that, how it would look like, the result of it. And then this is what the model outputted as the MSC. As you can see, like if I run this model again with different parameters and things, this will like, lower, get lower, maybe better, or even worse and get higher. So it all depends, right? So all this does, I'm loading it in and then I'm setting the X values. So like I did last time, this time I'm just setting the X values to the column name. So it's called hours. And remember, whenever you work with X data, you have to put in the double brackets. And then for the Y data, you would just need to set it normally without double brackets and say scores. And then everything else is the same. These are just like print statements, so you can just visually see each of the outputs. And yeah, and I think what my model also does, so this is where you can really see the machine learning part. So I'll just ran my code. So what you can do to run code is you can click this button here, or you can just do shift enter. Oh, file not found. Let's see. It's probably because it adjusted. Because I moved this. Yeah. Okay. So let's just say I want to do 7 hours, right? We created our model and now it's going to give us our actual prediction. It says you get a score of 71.717. It made a prediction. So this is, do you guys see how the AI is working here? It made a prediction based on our best fit line right over here. It just made a prediction and gave us our score. And looks like our model did worse because last time our MSC was actually 11.3 and now it's 11.5. So slightly worse, but it's still pretty accurate. But overall, does that part make sense?
Yes, sir.
Yeah.
Okay. Yeah, this code will also be available on GitHub. I forgot to put in the link yesterday, but I'll put it in today in Discord. Looks like our meeting will end soon. I think we can just use the same link. If not, I'll send in a new link to you guys on Discord. So be on the lookout for the new link. Yeah, let's get into the content I actually had planned for today. Let's dive right into it. Just making sure, can you guys see the workshop screen or no?
Yeah.
We can see it.
Hello, sir.
Yes.
Can I go to the washroom?
Yeah.
Wait, sir, excuse me. So wait, I wasn't here yesterday, so how do I install the Discord?
Wait, you're not on the Discord?
No, I'm not on the Discord.
There should have been an invite link on the form that you used to sign up with. If not, it's fine. I can just send it in the chat.
Thanks so much. Thank you.
No worries.
Sachit, I wasn't here yesterday, so can you send me the recording of yesterday after class?
It's on the Discord. Everything's on the Discord. So you'll be able to see it. There's a channel I created just for it. Just join the Discord and then yeah, recorded sessions. Just click on
Okay.
that and then you can find it. And make sure to react with the rules because that's really important so you can see the rest of the channels. Okay?
Okay. Okay.
Okay, cool. Where were we? Let's start. Okay. Can you guys see this?
Yeah.
Okay, so real quick, you just click on the plus. You can either click on your cell and do Shift Enter, or there's like a play button on the top, and you can click that to run the code. Also, let's get started. Okay, so day 2, introduction to AI and machine learning, logistical regression. Logistic regression. Yep. Okay, so again, reminder, please ask questions. Okay. So what is logistic regression? So logistic regression predicts the probability that a given input belongs to a particular category by fitting a curve to data using the logistic sigmoid function. Okay, right now, what I just said probably would not make any sense without like any like prior background to this. So I'm gonna like explain it much more clear. So let's get into it. Okay. The difference between like linear regression and logistic regression. So in linear regression, you have the dependent variable, which is a metric value in a linear regression model. So all that means is that you're doing it one variable to another variable. It's 1 to 1. It's not like 1 to 2, 1 to 3, right? But this time in logistic regression, we're doing the dependent variable is a dichotomous value in a linear regression. So what does dichotomous mean, right? Dichotomous is a variable with 2 outcomes or values. So for example, like male and female, and the dependent variable here is always categorical. So male, female, different things like that. So for example, if we want to make a logistic regression with a dichotomous value, and the dichotomous value is whether you have the disease or not, right? So now we can use this to predict diseases and see how the independent variable has an effect on whether you have the disease or not. So let's say, yeah, like I was saying, we can now understand the effects of other factors. For example, age, smoking, gender. You can now understand all of this have on the outcome of that disease. So 0 in this case stands for non-cancerous, and 1 stands for cancerous. So 0 and 1 is what we'll assign to the values. So right over here on the graph, this would be 0 and 1, and it'll go between these. So I'll explain more on why we need these values in a second. So we have our independent variables, age, gender, smoking, and our dependent variable. And our dependent variable, if you notice, it's 0 and 1. So let's get into it. And we're just checking if there's an influence. We can predict the likelihood of getting the cancer. So how do we use logistic regression in this case? So, like I was saying, logistic regression dependent variable must be categorical. So what is categorical versus quantitative variables? So first, quantitative variables are any variables that can be measured. So they can be either continuous or discrete. Continuous values like 0.1, 0.992. So like your weight, you can be like 70.2 pounds or 99.973 pounds. Like you have an infinite amount of possibilities, and that's continuous. And discrete is things that are countable. 1, 2, 3. How many crayons are in a box? 5 crayons. How many candies are in a jar? 100 candy jar. Like things like that. Okay. So categorical, these values describe qualities and cannot be meaningfully added or averaged. So basically, you can't really add in, oh, 3 green eyes plus 3 green eyes. I mean, you can't really do any statistical analysis with that, right? But like examples of it is male, female, those are categorical. Color eye, right? There's 7 pink eyes, 3 orange eyes, and 1 green eye. Right. So those are just examples of categorical. And looking at this graph, we see that if we put a linear regression on an axis that's restricted or restrained by 0 and 1, right? 0 being non-cancerous, 1 being cancerous, it goes infinitely out of it and it exceeds this range, right? So we can't use linear regression in this case. So what can we use? How can we compress this curve into this? So what we can use to predict now is logistic regression. So whenever you're working with this dichotomous values and you want to see how one independent variable has an effect on it, you can now use an S curve or a sigmoid curve. Now the predicted y is in the range of 0 and 1. Okay. Okay, perfect. So yeah,
Hello, sir.
yeah, yes,
It says that the meeting's gonna end in a minute.
yeah. So keep look at the Discord. I'll send in either a new link or I'm gonna send in the same link and tell you guys to rejoin it. So just keep a lookout in the Discord, okay?
Okay.
Yeah. So yeah. So we have our logistic regression model. We have no cancer and cancer, okay? And let's just say now how this works is, let's just say you have predicted that at age 70, the person has a 0.9% chance, not chance, percent, 0.9 value of getting that cancer. So that just means 90% chance of getting cancer at age 70. That's what our model predicts. Okay, so that's how you can use it for a prediction task. So that's how this AI machine learning project works. What it does is it creates this curve and then you can use it to make predictions. Yes, Prakia.
Why can't we use a linear regression curve?
Yeah, like I was saying before, a linear regression goes infinitely out of it.